Hey guys, so in this video I am going over the assessment review. There is going to be two other parts. Part 2 is going to be me going over how to find x-intercepts. In part 3 it is going to be me going over how to find your vertex in either your min or your max. So if you go to part 3, you can see how to find that vertex on the calculator. The steps are going to be put your equation into y equals on your graph or on your calculator, hit graph, then you're going to go to second trace to calculate something, and then you're going to calculate either your min and your max. For number 1, we are calculating a min or a minimum because it's going to be a upward facing U, because our A is positive. So it's going to be facing up. It's going to be a happy face. So once we do that, we know that our vertex is at 2.5, negative 8.5. On our graph, we're going to plot that. 2.5, negative 8.5, so right about here. And now we can go to our calculator and go to second table to get other points so we can graph. So I'm going to make a little table. And around this point we have 2, negative 8, 3, negative 8, 4, negative 4, and above that 2, negative 8 we have 1, negative 4. So here are some possible points you can use, remembering that you have to at least have 3 points on your graph for Tuesday. So I'm going to plot all 4 of these. So I've got 1, negative 4, so write 1, down 4, which will be about there. 2, negative 8, so write 2, down 8. Then 3, negative 8, so write 3, down 8. And then 4, negative 4, so write 4, down 4. So we're right here. So there is our graph. If we want to make a little curved line, should be looking like this. So then we can answer some questions. So the next one that we have is axis of symmetry, or your line of symmetry. So if we cut this graph in half, so it is symmetrical on both sides, it would be that green line that I just drew. Now all of your lines of symmetry are going to be involving your x values, because it's going to be the left side versus the right side. So we're going to have x equals, and either you can look at your graph to where you drew your line, or you can look at your vertex. Whatever that x value is going to be where your line is. Next one is asked, is your y-intercept. Your y-intercept always, and I'll change colors, your y-intercept always has to have an x value of 0. If the x value is not 0, then you are not on the y-axis. So every time for your y-intercept, you can go to your calculator, hit second graph or second table, and wherever your x value is 0, that is giving your y-intercept, and it's going to only have 1. Now, we are asked min or max, and where is it on the graph? So if we look at our graph that we sketched, we can pinpoint our smallest or lowest point on our graph. It is right there at our 2.5, negative 8.5. We cannot pinpoint our highest point. Our graph keeps going up forever, so even if we kept moving until we died, we still could not pinpoint our highest point. So we have a min, and our min is located at 2.5, negative 8.5. kind of already talked about the next one. The next one asks direction of opening. Well, we're opening up because our A is positive, so opening up. Then we have our domain and range. Our domain and range asking for X and Y values. So our domain versus our range. In between X and Y, what comes first? X. In between D and R, which comes first in the alphabet? D. So your X values and your D, or your domain, goes together. So only looking at your X values on your X axis, which is here. Do we go to the left forever? Yes. So we're going to go to negative infinity for our smallest X value. Do we go slowly to the right forever? Yes. So our biggest X value involved is positive infinity. Now we go on to range. Range is your up and down one, or your Y values. Is this graph going to go down forever? No. Our lowest Y value involved is going to be found at that vertex, or that minimum that we found, which is at negative 8.5. So there is a point at negative 8.5, so we're going to put a bracket. And then we're going to go find our biggest Y value. Well, our biggest Y value, we keep going up forever, so we do not know where our biggest Y value is, so we put positive infinity because it keeps going. Now we're looking for increase and decrease, so let me erase some of the things that are up here. So with that line of symmetry, it cuts it in half. So on our left side, following our graph, are we going from left to right? Following our graph left to right, are we going down or up? Down. So on the left side, we're going to be looking at our decreasing side. If this graph goes to the left forever, our smallest X value involved on the left side is negative infinity. And then we're going to keep decreasing, decreasing, decreasing until our X values get to that 2.5. And there is a point there, so we're going to put a bracket. Now for our right side, following our graph on the right side, from left to right, we're going up, or increasing. So we want to represent this right side by interval notation. So what is our smallest X value involved on the right side? It's at that 2.5 again. We're going to go slowly to the right, so we're going to go to positive infinity. So that is how you're doing number 1 on the assessment review. If you need to, you can pause the video and look at it, or try to attempt it yourself now. Going on to number 2. Number 2, we have a different equation. We're going to go to our calculator, go to y equals, and type this in. And go to second graph to go to our table, see if we can pinpoint our points that we need, or we can just hit graph, go to zoom fit, and now we have our graph. So we're going to go to second trace to calculate something, and we're going to calculate our max. Again, if you do not know the steps to find your min or your max, please go watch part 3. So your maximum for number 2 is at -3, -5. And then our table around this point is negative 6, negative 9.5, negative 5, negative 7, negative 4, negative 5.5, negative 3, negative 5, negative 2, negative 5.5, negative 1, negative 7, and 0, negative 9.5. So that is what your table should be looking like. If it does not, please go back to y equals on your calculator and check to make sure you put in your equation correctly. But main part, your negative 3, negative 5 is your vertex. So we're going to go graph that. Negative 3, so left 3. Negative 5, so down 5. Now, because there's a lot of decimals involved, I'm going to choose my negative 5, negative 7 above our vertex on our table, and our negative 1, negative 7. Again, just because they're whole numbers. Don't want to be guessing in between boxes on the graph paper. So negative 5, negative 7, so left 5, down 7. So it should be here. And I have negative 1, negative 7, so left 1, down 7. So this is our graph. Make sure you have 3 points on your graph on Tuesday. Now our line of symmetry, or axis of symmetry, is going to go through that vertex that we drew. So on that line, that x value is always going to be negative 3. So we're going to write it x equals negative 3. It is also the same x value as our vertex. Our y-intercept, we're going to go to our calculator. Well, it is already there for us. Wherever our x value is 0, our y value or y-intercept is there. So we have 0, negative 9.5. Looking back at our graph, do we have a min or a max? We have a max. We can pinpoint our tallest or biggest point. We cannot pinpoint our lowest point because the graph keeps going down forever. So we have a max, and our max is going to match whatever our vertex was. Does the graph open up or down? It opens down. So that would be the answer there. Asking for a domain and range. What is our domain always? Negative infinity to positive infinity. And the last few questions, our range. Well, our range is up and down because it's talking about our y values. Does this graph go down forever? Yes. So our smallest y value involved is negative infinity. Now, does this graph go up forever? No. Our highest or biggest y value involved is at that negative 5. So that is going to be our second part of our range. Our increase and decrease is going back to our line of symmetry. Which is at that x equals negative 3. On the left side, we are increasing. We are going from negative infinity to that negative 3. And then on the right side, we're going down, so we're decreasing, starting at that negative 3 and going to positive infinity because we're going to the right forever. Increase and decrease always talks about your x values. Number 3, we're asked the same questions that we've been doing. So number 3, we're going to go to y equals, type in our equation, negative negative x squared plus 2x plus 8. Hit graph. If we can't see all the key features, zoom 0. Again, if you don't know all these steps, please go to part 3. I'm going to hit second trace. I'm looking for a max. Left bound, then right bound. So my maximum is at 1, 9. So right 1, up 9. So I'm going to go ahead and put that for my vertex. It is also going to be for my max. Now I need to graph it. So I'm going to go to second graph to my table. Around this 1, 9, I want at least 1 point above and 1 point below on my table. So I've got x, y. At x is 0, I've got 8. At x is 1, I got 9. And at x is 2, y is 8. So I'm going to graph these 2 other points. 0 for the x value means nowhere left or right, and then just up 8. Then I have 2, 8, so right 2, up 8. And there is my graph. The next thing on my questions for number 3 is axis of symmetry. I draw a line through my vertex, a vertical line through my vertex. My x values are always going to be 1 on that line. So we're going to have x equals 1. That also is matching your x value of your vertex. Then your y-intercept, well, you already got your y-intercept on that table that I created at the bottom, because your x value is 0. So you have 0, 8. Direction of opening is opening down. The reason why, even if you did not graph it, you could see that it was opening down by our negative out front. Our domain is always negative infinity to positive infinity, unless we're working with a word problem. And then your range, are we going down forever? No. Or yes, we are going down forever. So your smallest y value is negative infinity. You're going to go up until you get to positive 9. And there is a point there, so you put a bracket. So increase and decrease, our line of symmetry is already there, so we can look at it. Here's our left side, our right side. So on our left side, we're increasing. We're going to go to the left forever and then come to the right all the way until we get to x equals 1. And that whole space, we're increasing. And then on the right side, we're going to start at 1, but then we're going to decrease on our graph until we go to positive infinity to the right. And there is our answers for number 3. Then we go on to number 4. Number 4, we have a construction worker drops a tool from a height of 75 feet. The function is listed there, and it models the height in feet after t seconds. So if we go to our calculator and type that equation in, we have negative 16. Instead of t, just put x. And if you need to on your paper, you can change it. Once I plug it into the calculator, I'm going to hit graph. If I cannot see all of the key features, I'm going to go to zoom 0. And then I can actually see what is going on. First thing I always want to do is find my maximum. So I'm going to go to second trace. first thing you need to do always is find your min or your max. In this case, I have a max, so I'm going to hit enter. I'm going to set my left and my right bound. My maximum is at 1.375. So I can go on my graph and do 1.3. So it's counted by 0.5, so it's somewhere in here. And then up 75. So approximately in between those two boxes. And then your y-intercept I can find by going to second graph or second table, and you get 0.75.